Hello everyone, this is Yuxuan Men. The topic of my presentation is incidence of azole resistance among non-African Candida species, and my supervisor is Dr. Parker. Introduction. Let me give you a quick recap from previous screencast. And Candida species are one of the most common cause of human fungal infections, and it causes a range of infections including bloodstream and other systemic infections, and result more than 1 million deaths annually. Around half of the Candida infections are attributable to Candida albicans, with the remainder caused by non-albicans Candida species. And azole exerts the fungostatic activities by inhibiting the enzyme called elanosterol 14-alpha demethylase, encoded by the ERG11 gene, which could block the ergosterol synthesis and accumulate toxic sterol, which produced by the ERG3. So that brings us to the mechanism of azole resistance. The rise of the antifungal resistance compromised the effective treatment of the invisible fungal disease. ERG11 point mutation caused a change in amino acid, which affect the whole azole bond to the ERG11 and inhibits the activities. So let me introduce this 3D model. This is a tetrastructure of the wild-type ERG11 from the C. albicans, and amino acid substitution affecting the resistance to one or more of these azole inhibitor occurs in the catalytic site and between the proximal surface and heme. As you can see from the right bottom picture, the azole binding site is highlighted. That active site consists of amino acid residues that form temporary bonds with the substrate and residues that catalyze a reaction of the substrate. Although it is not only 10 to 20% of the volume of enzyme, it is the most important part as it directly catalyzes the chemical reaction. So it is required to maintain the tetrastructure of the enzymes. So now we know that the cause of the azole resistance in Candida albicans is well understood, but the non-albican Candida species are still lack of research. So therefore, I made a hypothesis is that the use of azole antifungals is causing an increase in resistance in non-albican Candida species. So the methods, there are two methods being used in this review: systematic literature review and the bioinformatic analysis. So the systematic literature review was conducted throughout the project to assist in data collection and integrate the information. Literature relevant to the ERG11 mutation and amino acid substitution will be used in the conjugation with the bioinformatic approaches, and the bioinformatics analysis was conducted to analyze relevant prevalence and visualize the resistance related hotspot regions, and it will also help us to identify the newly deposited sequence which may be carrying the resistance mutation, and make the further experiment to detect it. So how do we test whether it's resistant to the azole or not? For the antifungal drug susceptibility testing, there are two methods widely used, which are CRSI and EU-CAST. The MICs generated by the two methods were overall very similar, and this is how the breakpoints are determined. Innate resistance level are various in different Candida species, and take C. aureus as an example. It has been high resistance level with fluconazole, distant to lower resistance level with posaconazole, and this table is adapted from the And here is a clinical breakpoint and the ECOF for the Candida species, and some take-home information such as the profile of the epidemiological cutoff and the clinical breakpoint in EU-CAST for Candida species is proved the resistant correlation between different NAC species. In this profile, there are 3 different procedures in use, which all uncovered in the EU-CAST. This is the table of Candida albicans ERG11 mutation associated with resistance, and you can see from the table here, the blue highlights substitutions are associated with resistance, and the green highlights are those do not confer azole resistance. I used the cholesterol omega to make the multiple sequence alignment for Candida species erg11, and this enabled us to identify the corresponding resistance mutations in other Candida species. As you can see that the top one is a little bit unclear, and I made the highlight the one below the substitutions which associated with antifungal resistance. Then let's move on to the Candida auris erg11 mutation, which caused the resistance. And as mentioned before, C. auris fluconazole MSC breakpoint is larger than 32 microgram per ml, and compared to the resistance reports, can help us to make the table of the resistance associated substitutions. And however, this table is not finished yet, and I will spend the next few weeks collecting data and completing the resistance profile of erg11 mutations, which caused resistance in non-albicans Candida species. So the conclusion, the level of the innate resistance varies between the Candida species, and different clinical breakpoints are required to determine whether the relevant substitution is associated with resistance, and the resistance caused by substitutions at the same site in both Candida albicans and the non-albicans Candida species could thus demonstrate that they have similar mechanisms of the resistance. And I will continue to complete the resistance profile, further demonstrate that the clinical use of the azole caused resistance in non-albicans Candida species. And thanks for listening. Do you have any questions?